How you doing? Like my hair? You gotta have hair like this to do science. So work on that. When you're ready, pause the video. Come on back. All right. So we're doing something here called craters. Craters are often made either by a volcano from within the earth exploding out, forming a crater, or something from outside the earth, like a meteor smashing into the earth. So it's a lot of energy being dissipated all at once. Now it's your chance to experiment with a few of these variables. So here's the supplies you're going to need. A bit of sand, some sort of container to hold it in. I use a cardboard box because that way I can smash it up and push holes in it. It's okay. A few rocks. I got a, golf ball-ish size rock. I got some little pebbles. You could do things like, I don't know, you got like a Lego figurine. You could do some, I got a piece of plasticine because it's softer, right? Softer than the rock. I'm curious how that might make a crater. Okay. Apart from that, you're going to need something to measure with. Okay. And then a straw. I couldn't find any plastic straws with the little bend at the end. Like a juice box one would be perfect. I didn't have any. So I'm just going to use a piece of my tubing from the hardware store. It's really handy. Any type of tubing would work. Even a garden hose. If you had a chunk of that, or just a tube. It's not that complicated. So, ready? Let's do it. This experiment has two parts. The first one is actually doing the meteorite kind of test. So what would happen if something from outer space came in and impacted our Earth or another planet, right? We look at the moon and we see all sorts of craters. It's been bombarded, smashed by craters over a long time. So take your area of sand and smooth it out. So I just have a piece of Lego because that's easy. Can you think why we need to smooth it out? Yeah. So when something hits, we can really easily notice where the the impact is happening in the crater and such. So one way to test for craters is to get a certain height, figure it out. Maybe you're going to drop from 30 centimeters height. Wasn't that exciting? That's okay. It'd be good if the Earth only got hit by something like that because I can't handle much more excitement. So do a few drops with meteorites of the same size and measure how much of a crater are they forming. Then, if you want, change your variable. Either keep the same small meteorites and make the height you drop bigger, okay? Or keep the height the same, but change to a bigger one. Ooh, it's kind of like a ring around the edge there. Okay. A few other things you might want to be aware of are the materials you're using. So I have something called masonry sand. It's very fine sand. I was able to get it at a hardware store where they sell different types of gravels and stuff. It's really fine and it's great when it's dry. So the drier you get, you're going to get more explosive energy and probably more noticeable craters. At the same time, once you try it with dryish sand, I would recommend grabbing some water and getting the sand wet. Try it that way and see if you notice any difference. Not all planets are the same material, right? Some planets are going to be impacted by a crater that kind of hold together and don't crater. and other ones that may have different material, maybe more liquids that all of a sudden explode, or maybe they don't because of the liquid. That's something to think about. Um, oh, and if you don't have sand, you can use flour, like baking flour. Yeah, ask a parent, please. It's kind of messy, but it's really cool. Flour is so fine, you're gonna end up with a mess. But if you can do it outside somewhere and sacrifice a bit of flour for science, you're going to get some really cool effects, some really interesting circles around that. So that's another variable. So what is your planet made out of, right? What size are your meteorites? And from what height are they dropping? So that's going to affect the speed. The longer they can drop here on Earth, as high as we can drop, they're going to get faster and faster. Okay. Eventually they hit a speed where they don't get faster, but you can't do that. The other thing you could do, and I know the science or your lab report says, try a slingshot. Um, that's another option. At this range, I would be wearing something to protect my eyes. But you could, if you wanted to, take a slingshot a couple feet away and hit it with a rock. The little guy, right? It's going to get sucked in, but it's probably going to dissipate that energy in a way that causes the surrounding material to do something. Okay. When you're done all those things, measure, record your data, big meteor, small meteor, spongy soft one, super fast one. That's all good. The second thing you got to do is try out what's happening with volcanoes. Okay. So I'm going to shuffle my sand to one end. Oops. And I've punched a hole down in this end. You probably can see it. There we go. I'm going to stand it up and I'm going to collapse a bit more sand towards my tube, compress it around it. The nice thing about this masonry sand is it compresses so well. Other things like bedding sand would be okay. Playground sand would be fine. Something from like you'd see like that same stuff in like the long jump pit. You could use things like flour. You could use something like cornmeal. Anything with that gritty consistency. I mean, you could try mud, right? Like imagine that hitting really goopy mud after a good rainy day in the spring. Is it going to make a crater? How big? Does mud make a better crater? Find out. Yeah. Okay. So, got a bit more sand. Remember, I want my surface to be nice and uniform without any streaks or anything, because that will help me figure out exactly what is caused by my volcano in this case. I think, how is this a volcano? Oh, just you wait. Can you see that? My little straw. I'm going to push it down just a little bit, so I've got the other end right here. Okay. And now I'm going to take some of the dry sand and just gently pile it on top. Smooth it over. Ooh, it's going to be awesome. And a volcano has all this energy trapped underneath the Earth's crust. Ready? Here we go. Probably going to cover my eyes. Oh. Can you see? Oh, I can. That's a cool crater. Wow. So I can measure my crater, figure out the depth. I can also figure out how much material was put on top of it. I wonder if I pile more material and the energy ball, like that magma part of the volcano is way lower with all that earth above it, the crater may be bigger. It may not. It may just be nothing. Probably not. Probably not. Try it. Anyway, that's a volcano. Meteor.